Welcome to the biohackingmyillness.com podcast, biohacking your way to optimal health. The content of this show is for informational purposes only and is not intended to diagnose, treat, or cure any illness or medical condition. Nothing in today's discussion is meant to serve as medical advice or as information to facilitate self-treatment. As always, please discuss any potential health-related decisions with your own personal doctor. And now, your host and biohacking coach, Dr. Arthur Mariano.
Hi there, and welcome to another episode of this podcast. I should say that I've been getting a kick out of doing this episodes, and today it's such an honor to have Dr. Boyd Haley here with me. I'm very interested in heavy metal chelation and toxic metal chelation in general. I should say that this podcast is really, really special, and there's a disclaimer that I should put forward up front, which is OSR 1 is not on the market right now. So this is an experimental drug that people cannot use. And as any podcast, this is really for informational purposes only. But keep in mind that this drug, Dr. Haley's, is trying to complete some clinical trials to get the drug approved by the FDA. But in the meantime, just take all this information with a pinch of salt. You're not going to be able to discuss it with your doctor. That being said, I think it's such a great value right here. I pretty much tried to ask Dr. Haley practical questions that were usable for my own case, as I have used OSR myself in the past, and if it is approved, I plan to use it again in the future. But and so the reason for the practical questions. I hope you enjoy this podcast. Take it lightly with a pinch of salt because of what I said, but do embrace the information that is discussed here. I hope you enjoy it. So I've been very interested in heavy metal chelation or toxic metal chelation as I'm chelating myself. And today it's a very special show because I have the honor to have Dr. Boyd Haley with me. Dr. Boyd Haley is the creator of OSR 1 or at MBI. The compound goes by several names. And thank you so very much for being here today, Dr. Haley.
It's my pleasure.
Okay, so let's get right into it because I do have a lot of questions. First question, why did you develop OSR in the first place?
Well, I developed a technology that was funded by about 25 years by the NIH. It's called nucleotide photoaffinity labeling, and we don't go into that. But what it does, it allows you to look at a diseased or a toxic tissue and see what enzymes are affected. So I did that. And then I had a graduate student that went to work in the Aging Center at the University of Kentucky on an Alzheimer's project. And she told me that they had no idea what caused Alzheimer's disease, that there were speculations, but no one knew. So she and I started a project when we were looking at the changes in enzymes in the Alzheimer's brain that did not occur in any other disease type of brain tissue. And what we found was that this was tubulin, the major brain protein, was disrupted, and and everybody believes that. I mean, no, that was published in the best journals in the United States, and everybody still agrees that we were right about that observation. But then the next step is to find out what causes such a thing. As you understand, the NIH says it's beta amyloid. It's an amyloid-induced disease. That's a compound or an enzyme protein that's in the brain of everybody that lives. And so it didn't make sense to me. And so I read a book where they were following the lives of 200 identical twins from the American military from World War II, trying to decide if diseases were caused by genetics alone, or was it increased susceptibility to an environmental toxin. And what you found was that Alzheimer's disease was that. It is not. I mean, you can have a set of identical twins, one will get Alzheimer's and one will not. So it depends upon an exposure, and it's an increased susceptibility to a toxicant, an environmental toxicant, not something that's in your body.
Right.
And so at that time, it was kind of popular to think that aluminum was causing Alzheimer's disease. And I don't know exactly why, because aluminum pots and pans came out and exposure increased when Alzheimer's increased. And so we decided to look at the tissue. And what we found is that tubulin, which is the major brain protein, and tubulin is a protein that covers the neurofibrils that go out into the brain and make connections to other neurons, between neurons in the brain. And so we decided, well, I decided that I was going to find out what would cause this. Is there a toxin out there that's common that would cause this? So we started out with all, most likely because of the aluminum concept, aluminum, mercury, lead, cadmium, and all those things. And the only metal that would mimic, and it mimicked it perfectly, what you see in Alzheimer's disease was mercury. And it took very low levels of mercury to cause the tubulin in the brain to become abnormally aggregated and behave like an Alzheimer's disease brain. And we published that. That's been published for a long time. However, our NIH did not like that. They wanted the cause to be beta amyloid protein. They didn't want the cause to be an external cause. That's my opinion. I don't know that for certain. I mean, and when you say NIH, you cover a lot of people, and there are people there that believe me, and there are people there that follow the bureaucracy, because pharmaceutically speaking, if it's beta amyloid, there was a big chance that the pharmaceutical companies could make a lot of money making a drug to treat that. And to make a long story short, to date they have totally failed trying to treat beta amyloid as a cause of Alzheimer's disease. As a matter of fact, they've even killed people trying to get rid of the beta amyloid. It's necessary in the brain. And since that time, every major diagnostic observation you see in Alzheimer's disease can be mimicked by mercury in the appropriate testing system. For example, if you treat neurological tissue with mercury, beta amyloid plaques develop. And the reason it does that is that they have shown, this is from South Korea, a university, mercury inhibits the production of neprilysin, which is a protease that's designed and released in the brain to chew up beta amyloid plaques. And so mercury inhibits the enzyme, the production or release of the protease that chews up beta amyloid, and therefore beta amyloid builds up. But you can have a lot of beta amyloid in certain people and still not have Alzheimer's.
Right.
And so mercury makes that, but you won't get any support from our NIH or government agencies to look at heavy metals like mercury that we put in the mouths of all of our aged Americans and now children. It's a toxin that makes
which is considered to be safe today, right? Which is kind of mind-blowing, but amalgam fillings, they know that they have mercury and it's still regarded as safe.
Yeah, when I first got into this, I thought all I have to do is really convince the people at the FDA that mercury comes off of dental amalgams at the level that I was seeing. And I studied it. I didn't believe it at the start either. But I can tell you, they don't want to hear that. They do everything they can to downplay the fact, because the amalgam fillings is a compound. Dental amalgams are approved by the FDA and the the American Dental Association and the National Institutes of Dental Treatment and the NIH. So it's approved by the government.
Yeah,
and it's
the same story in Europe, so it's pretty much everywhere. So you developed OSR because you were convinced that an external toxin exposure was the cause, for example, of Alzheimer's and other diseases. Am I right?
Well, see, that you got to understand, what would convince some people. And as a scientist, you've got to carefully separate what you think from what you know.
Can prove, right?
Yeah. And what there has never been a study looking at dental amalgams and level dental amalgams in Alzheimer's patients. You'll never get it funded. And if you go to NIH and say, have you ever funded a study to do this? You'll find out they have never funded a study. It would never get funded because the National Institutes of Dental Research is in the NIH, and they would veto it. I mean, they would just stop it. I mean, it's the most obvious thing to do, especially from where I'm from, for aged Americans or aged Europeans. Are those amalgams in your mouth doing you damage? You have to be an idiot to think they're not. You can take a vapor sniffer and put it in the mouth of somebody with a dental amalgam and measure the mercury coming off, and you're breathing it every day, every minute of every day, and mercury is toxic. That no one has ever done an experiment exposing animals to mercury vapor that did not make those animals sick.
Right. Yeah, I agree. We would have to be idiots not to think that at least it causes some damage. So moving on, technically speaking, why do you think that OSR is a superior chelator of mercury and other metals compared to other chelators?
Well, what I can tell you about it is that what other chelator would you use? I mean, there isn't one out there. DMPS and DMSA are the two chelators that are used to treat mercury toxicity. And if you look at them, they both have sulfurs on adjacent carbons. In other words, the sulfurs are held rigidly this close together. They can't go out like this. They can't move around. And there is not enough room stereochemically in between those two sulfurs, like my fist, for mercury to fit. So mercury, and this has been published and in the stereochemistry looked at, what DMPS and DMSA does is one mercury sulfur will go out and bind to a mercury, and then another DMPS will go in. So it forms a sandwich complex. In other words, the structure is really DMSA, mercury, DMSA. And that means you got one sulfur bound per atom, and they can exchange easy. So DMPS and DMSA are very good at transferring mercury from one organ to another and spreading it around the body. And that's been published. So they are not true chelators. They form a sandwich complex. In contrast, and I took this into account because I was talking to a lot of dental friends because I was much involved with the International Academy of Oral and Medical Toxicology, and people would take DMPS and they would end up with kidney problems. I mean, pain, and they would just say they wouldn't take it anymore. And so what I knew we had to do is we had to make a chelator that would totally surround the mercury atom and make the electron shells unavailable for reactivity and make a very stable bond. Now, at the University of Kentucky at that time, I was chairman, and I hired a young man by the name of David Atwood. He came in. He was trying to develop chelators to treat mine water. And he was doing, and one of his students, Matlock was his last name. Matlock found a compound that had two thiol groups held out on long arms, and this is what we call having degrees of freedom of rotation. In other words, this is a sulfur and this is a sulfur, and so they can move around and they can rotate like my arms, and they excuse me, can form structures or the bonding angles to hold mercury. Anyway, once it binds it, you have two thiols on each side of the mercury, which makes the most stable complex of mercury known. And what we found out in our testing, because I was on his thesis committee, and rather excited about it because I noticed that it was hydrophobic. And my idea, if you're going to make and I had a grant at that time to make a hydrophobic chelator for mercury that would get into the body and then inside the cells, because charged compounds like even lipoic acid has a very hard time getting inside the body unless it's a carrier taking it in. And anyway, when you mix this compound in a hydrophobic mixture or solvent like ethanol or methanol and added that to mercury and water, when it bound to the mercury or the iron or the cadmium, what it would do, it would form a neutral complex that was insoluble. and it would be bound thermodynamically irreversible. In other words, the mercury, when it bound to NBMI, would precipitate out, and you can see the precipitate at the bottom of the test tube.
Wow.
Then you could take that precipitate and test it. You could try to dissolve it in anything you want. It will not dissolve. The only way you get that mercury off of there is to incinerate it, destroy the structure of the compound, the NBMI.
Right.
And
so the first advantage of OSR compared to other chelators, which are not true chelators, is the fact that there's a lot of flexibility in the structure, in the molecular structure of the compound, to grab onto metals and not letting them go. Is that right?
That's right. We call that thermodynamic irreversibility.
Right.
Now, I mean, if you make mercury NBMI and add other metals to that solution, try to get it to exchange, it won't exchange. But if you make iron NBMI and add mercury to it, it will displace the iron.
Right.
So it binds all of them thermodynamically irreversible, and they're not charged. But there is a preference. We can get a preference. Which metal does it like binding the tightest? And NBMI likes binding mercury tighter. Binds mercury tighter than anything. You can't displace that mercury at all. And now, but this does bring up something that your colleagues, people who listen to you, should know about. When you treat somebody with NBMI, you not only chelate toxic mercury, you get out toxic cadmium, gadolinium, iron.
Right. That was actually the next question. So what toxic metals does OSR chelate? Or if you prefer, which ones does it not?
There's none that it doesn't chelate. I mean, iron is in your body, and that's probably the one that binds the weakest, iron and copper, and they're only toxic if they're free. I mean, if we take rats and give them 1,000 milligrams per kilogram body weight, which is a huge amount, we do not displace any iron or copper. Right. It's normally bound there, even though this compound would bind it tighter. And that was my major worry about the compound, is that it would deplete the essential metals from specific binding sites. It just doesn't happen. And the reason I think it doesn't happen, if I have to explain that, then I should, is that hemoglobin and copper binding proteins are all water soluble. They're very much in the aqueous phase. NBMI doesn't go there. I mean, it gets into the lipid bilayer and it kind of stays there. And the only thing I can tell you is by experiment and everything we've done at huge amounts, huge doses, NBMI does not deplete iron or copper in test animals.
Gotcha. And that's also the reason why NBMI goes inside the mitochondria to chelate metals inside the mitochondria, because there's a lipid barrier in the mitochondria. Am I right?
Right.
And not water. Right.
And we know it does that, by the way, because when we look at the some of the enzymes that are inhibited by mercury, they're on the outer aspect of the inner membrane of the mitochondria, and NBMI will reactivate them.
Oh, wow.
Yeah, pulls the mercury off and they become reactivated.
Gotcha. So OSR, I'm sorry, I still call it OSR, binds metals that are unbound pretty much freely, circulating in the body. What about minerals? We talked about iron. Iron is a super important metal in the body because of hemoglobin, but it doesn't go there because it's not bound to any lipid substance that NBMI can go inside and grab onto, if you will. But what about minerals? So is it safe to take OSR, a mineral complex supplement, right after, for instance? Will OSR bind to any of the minerals?
It has no affinity for most of them. I mean, like calcium and magnesium. The only one that would have affinity for is zinc and copper.
Okay.
And I would suggest, if you're going to take zinc and copper supplements, that you take them at least 3 hours before or after you've taken NBMI.
Gotcha. No affinity for potassium as well, right?
No attraction. You can take it with potassium or calcium or sodium. They don't. It doesn't bind to that at all.
Okay.
And see, that's the advantage. The compound is neutral, whereas if you look at DMSA and DMPS, they both have a negative charge on them at pH 7. I mean, they're negatively charged, and so there's a charge negative. The sulfate on dimethyl propane sulfonate has an attraction for sodium and potassium, and it will help carry such molecules and magnesium and calcium out into the urine. It causes a depletion.
Gotcha. Is there any difference between taking OSR with food or without food?
Well, we tested that, and if there is a difference, there's certainly a difference, but it's minimal. I mean, you can take it with food if you want or without food.
The minimal capability you're talking about, that there's, the minimal difference between taking OSR with or without food, is it in the chelating capability of the compound?
No. It's if you eat a fatty American breakfast with a lot of fat, it seems to enhance the uptake of NBMI. So if you eat if you want to be very basic about it, if you can get it more soluble in your stomach by eating a fatty acid, breakfast or some fat, that probably enhances the uptake.
Right.
It's minimal.
Gotcha. So if we take OSR far from the meal, but we dissolve it in olive oil, for instance, or coconut oil, that would be comparable to taking it with a fatty meal. Am I right?
That's right.
Okay.
And by the way, when we treated some autistic children when it was called OSR, and the one autistic child would not take
any oils,
anything. I wasn't there. I'm not her mother, but her mother told me she would. So the mother gave her the NBMI by mixing it with olive oil and rubbing it on the thighs of her legs. And it got in there because her glutathione levels elevated, and she improved dramatically.
Right.
So, you can do transdermal delivery of NBMI.
Gotcha.
That's possible.
That's how to take it. Now the question is when to take it. Is there any difference in the exact time to take it? Is there any particular time of the day that we should take it?
There may be, but we haven't found it.
Right.
We take it all the time. And, and people are looking at somebody that's been taking this compound daily since about 2006. I take it and, because I'm a crusty old guy and I know what it is.
You're about 50 years old. Let's make that clear.
I'm 82. And I put the compound in the palm of my hand with a scoop and throw it in my mouth and take it in my mouth. And I do it anytime I think about it. And it builds it up. And I can tell you, I have not had a single adverse effect from the compound that I know of. My vision has actually improved a little bit. I don't have a glaucoma or I don't have cataracts since I've been taking it. So the compound and this is something, again, I want to make it clear to everybody. I don't think I know all there is to know about the best way to treat this with this compound. That is the reason I have to get it approved through the FDA or some group. Once it's approved, then it gets in the hands of medical doctors or groups that can test it with and without eating, say, peanut butter or whatever, how well it works. I can't do that with everybody. I'm an N value of 1. All I can do is I took it because I didn't want to give it to children, because without knowing that it affect your vision, your brain. And the only thing I can tell you that there's certain things I did notice about myself. As you can tell, I'm from a type A Irish family. We're very high strung. And we go full time. And we all have, when we get older, we all have a little bit of a tremor. I lost my tremor. That's the hand of an 82-year-old guy. It's pretty damn stable. And
just to be clear, you had tremors before starting OSR?
Oh, yeah.
And oh, wow.
And I know it because I did a lot of pipetting. I was very active in a research lab.
Right.
My first love.
That's where you notice it, right? That's where you have to have precise hands. Precision is really important in a lab. So this is all very interesting. But you also mentioned eye vision. Do you know any stories of OSR reversing eye floaters? Because eye floaters are pretty common with mercury, I think.
Yeah, but again, we go back to what I know, what I think from what I know. I have talked to several people, older people like me, that started taking OSR or NBMI, and they would say all of a sudden that their vision improved dramatically over a period of time. It cannot change if you have bad cornea, etc., it can't do that, but it can reverse and stop cataracts. Cataracts are oxidation of the thing. And if you take NBMI, there have been people who told me that, and one of them is my wife, who was scheduled to have cataract surgery, and then later, after taking OSR for a long time, didn't need it.
Oh, wow.
So, but that's an NBI one. That's so I think it does help fight cataracts, but I don't know that.
Right. Gotcha. Just to finish this section, because one of my followers required this question quite a lot. OSR does chelate deep stored lead and also gadolinium, right? Just to make
it definitely. I can tell you, I know of 5 people that have contacted me and for advice, like you were talking to me now, that had gadolinium toxicity from taking MRI contrast agents.
Right.
And it has helped every one of them. Now, did it totally reverse it? Did we do the experiments to show that the gadolinium was out of their body? No, I don't have that. I don't have that capability now. But
this is anecdotal evidence. Yeah, this is anecdotal evidence, but it's still very valuable. We understand that we would need larger studies, more people, more clinical trials before and after to really determine and assess the compound. But this is right now we have to say what we know, and this is very valuable information.
Okay, with lead, we have had several, and there is a publication from the University of Massachusetts College of Pharmacy showing that our compound would prevent lead toxicity in brain cells and culture much better than DMSA, which was what the FDA had improved, and that's published. And I think I sent that to you.
Yes.
And,
I actually read that.
Those people are totally independent of me. They wouldn't, if I told them to do something they didn't want to do, they would just tell me to buzz off without any problem. I mean, I like that.
Right.
But lead, if you understand lead toxicity, lead builds up in your bones. And I'm aware of that because I knew Dr. Needleman, who fought the lead toxicity for a long time. And lead builds up in your bones and slowly comes out. So when you take somebody that has mercury and lead toxicity and you give them NBMI, the mercury will drop dramatically, very quickly. But the lead goes down in very small increments because as you take it out of the blood, more comes out of the bone. And if you do it for a long enough time, like I have, all your lead will be gone. But it takes a long time.
Could that also be explained by the fact that OSR has a higher affinity to mercury than lead, and so the mercury drops faster than the lead?
No, I don't think it's gotten. I think both of them have both of them have
Affinity.
very high affinity for both those metals. So the reason the lead drops slowly is because your body
is deep stored in the bones.
It's constantly coming out of the bone and getting into the blood,
but
it does that slowly. And NBMI can go into, say, like your liver or your kidney and bind mercury, but it can't go into the bone. I mean, it's hydrophobic and the bone is mineral. Minerals don't like hydrophobic compounds.
I understand. Is there any particular metal that has a higher affinity for OSR, or OSR has a higher affinity for that metal? Or do you think that they are all equally, there's an equally affinity?
No, there's definitely a status. You can't measure the binding because the binding is very tight for all of them. I mean, so it would be very inaccurate. But if you, like you say, if you make a precipitate of NBMI with mercury and add iron to it, and then you try to look at mercury being released from the pellet, because it's a pellet in water, you won't get it. It never lets mercury go free. But if you put iron on the NBMI and make a pellet and then add it to water and then add mercury to that, you'll see that mercury will slowly displace the iron in the complex. So there's a binding hierarchy. Mercury binds the tightest, then lead, then cadmium. And that was all worked out by our graduate students by doing these competitive displacement studies. But you can't measure it because all the metals, if you look at them, are what they call it thermodynamically irreversible. In other words, there's such a slow off rate that they're not soluble.
Right. I mean, we actually started this conversation with aluminum, but OSR does not bind aluminum. Am I right?
It does not have high affinity for it, no.
Right. So it would be like a equal affinity to aluminum than to say copper and zinc.
I wouldn't say that tight. I mean, copper and
Gotcha.
zinc bind to NBMI very tightly. I mean, you can totally tie them
Wow.
up, but there's nothing else there.
But you would
And
say still that the toxic metals like thallium, for instance, would bind tighter to OSR than copper and zinc. Am I right?
yes, they
Okay.
do.
So
The copper
they
and zinc-
come later in the list, essentially.
Yeah. On our list, if everybody look at the publication, you'll see that we have mercury at the top and copper and zinc at the bottom as far as affinity going. And
Okay, thanks. That's helpful. What is the best way, in your opinion, to determine whether a person is metal toxic? Would it be running an HTMA test, hair test mineral analysis, and assess mineral derangement? This is quite popular in the anti-kettler community. So there's a question.
well, you know, you're talking human beings. They're not going to let you do a biopsy on the liver. I mean, if it were an
Absolutely.
animal, we take the thing and we take out chunks of tissue and dissolve it and measure it. You can't do that to humans. So for humans, the best testing, I think, is checking either the urine or the blood. Now, there's a problem there because people who are poor excretors do not put as much mercury in their urine as do people that are good excretors. And that goes all the way back to a study done in the 1970s in Yugoslavia. Yugoslavian is in Slovenia. They had a chloralkali plant where they had a major breakdown, and all the people in the plant became mercury toxic.
Oh, wow.
And then they came up, they did a study, they treated them with whatever they had, DMSA or DMPS, and they came up with a conclusion that the people, and they said this, they had a conundrum. The people that were the most mercury toxic got well faster. Now, how they determined whether you were the most mercury toxic was the level in your urine. And see, more than likely, the level in your urine was more dependent upon your ability to excrete, because otherwise that makes no sense at all.
Yes,
And so
I mean, that's the same for every kind of toxin. We test mycotoxins in urine, and some person who's healthy has a higher amount of mycotoxins than someone who's very sick from mold illness, right? And it's the detox capability, and that's why some people provoke these things to come out. So essentially, this happens with metals, taking DMSA and DMPS before the test to provoke them to come out, but the detox capability would still have an impact for sure. I'm just surprised that you think that blood and urine are preferential methods to assess toxicity compared to hair.
I think blood and urine are better, but
Gotcha.
I mean, because people do a lot of crap with their hair, and your hair is out and it's being exposed to the environment, and so I just think I think urine is the
That's a
best
very
one
good point.
because it's the least invasive, and if it's there, it shouldn't be there. I mean,
Absolutely.
mercury and lead, if it's in your urine, there's some in your body, but you don't know how much. And we don't have that technology developed yet. Now they're getting some instrumental technologies that allow you to look at the unbound iron in the brain and things like that. And so that may change in the future. But right now, just if you live in this world, just assume you're heavy metal toxic, because you probably are. If you're eating fish or any seafood, just assume you are. If you're having medical problems. And the thing I like about OSR is it's totally non-toxic. You can take it for a week and clean up your body. Because we have done this with rats where we've given them mercury toxicity and showed that their kidneys were falling apart, and then give them 1 or 2 doses. We did a whole week, of course, but after 1 or 2 doses of NBMI, the toxicity ended. And we have used the H67D rat. That's a rat that develops high levels of iron. It can't get rid of iron. And it's for hemochromatosis. It's a model for hemochromatosis and Parkinson's disease. And if these rats are allowed to develop normally, they they become demented, they lose the functionality of their limbs, and they lay down and die. If you give them NBMI, that doesn't happen. And if you look at the brain, there's a buildup of iron, free iron in the brain with these rats. And with that, they get oxidative stress. You get markers for oxidative stress. And when we give these rats NBMI, because NBMI gets into the brain very easily, and the animals didn't get sick, they didn't die. And when you measured the amount of iron, unbound iron in their brain, it was much lower than if they weren't treated. But the interesting thing was all of the oxidative stress in the treated mice that were H670 rats was lower than in control rats. In other words, NBMI was getting in there, binding iron and lowering the oxidative stress to levels lower than controls. So there is something very good about taking this compound. And if you look at some of the studies we've done on cells and culture, you look at the reduced glutathione in cells and culture that have been treated with mercury or not treated with mercury. And when you give them NBMI, they both show an increase in reduced glutathione. So it's even causing healthy cells to keep their glutathione levels very high, because cultured cells are, they're slowly dying.
Right. I'm actually going to ask you something about the glutathione producing capability that OSR seems to induce in healthy cells. I just remembered something because you talked about seafood and the fact that seafood is highly contaminated with metals. Tonight, I actually last night, I dreamed of this, and I wanted to ask you this because you brought it up. If we had a meal that contained seafood, would that be the best time of the day to take OSR, because it's probably going to bind to the metals that come in the seafood?
It's what I do. I do it before. If I'm going to go out and I know I'm going to eat seafood, I take the OSR before. Gotcha. Because it stays in your body, half-life of 22 hours.
Yes. How about lactoferrin? So I use lactoferrin to bind iron, and I reckon that using lactoferrin to bound the unbound iron in the body, and then using OSR later on, is going to maximize the usage of OSR towards other metals. Is this overthinking?
I understand what you're saying is reasonable, but I don't know that. I mean, I have not done any experiments with lactoferrin.
Why do you think that people react to single drops of transdermal OSR, while others can get away with thousands of milligrams sometimes without any kind of side effects or side effects at all? Does it have to be with their toxic load, bottlenecks like poor methylation capacity, poor detox capacity in general, or even sacylate sensitivities that could explain this?
I would have to see people have a negative response to a single drop of OSR before I would believe it, because I've rubbed it all over my hands when I first started. I mean, I was trying to induce some sort of skin toxicity, but what I can tell you is that the people, when we sold it as OSR, primarily the people that bought it were parents of autistic children. And the people that had a negative effect, and this is held up throughout all of our studies, people that respond negatively to NBMI or OSR are people that are thiol-sensitive. They can't take sulfa drugs, for example.
I'm thiol-sensitive, by the way.
Yeah. Well, and those people can't drink wine because of the sulfite in the wine. And if you look at autistic children have 50 times the sulfite level on the average. This is from Rosemary Warren, a doctor in England who did a study on this, and that indicated that they are not metabolizing or getting rid of the sulfur as effective as other compounds. And I read that a long time ago. And what you find out then, and in her paper, she said, if you gave them molibdenum, some of them improved. Well, molibdenum, and I did a lot of research on this, and so I don't want to take credit for other people's work, but I did a lot of work trying to find out how does molibdenum affect sulfite sensitivity. And what I found a long paper published a long time ago where doctors found that children that had high sulfite levels were going to die. I mean, if they were infants and had high sulfite levels, their ability to live was dramatically reduced. And then you look at it, and what you find is in a metabolism of getting rid of regular sulfur, we all have to get rid of certain things. Regular sulfur, like would be on the end of NBMI or DMSA, has to be converted when it's released to sulfur, and it has to be converted to sulfite, SO3 minus. And that's what builds up in autistic children. Now, sulfite oxidase is a compound, an enzyme in your body that takes sulfite, which is toxic to you. That's the reason people who drink wine, if they take molybdenum, sometimes they lose their sensitivity to drinking wine that's preserved with sulfite.
Right.
Molybdenum binds in a cofactor for the enzyme sulfite oxidase, which takes toxic sulfite and converts it to non-toxic sulfate, which your kidney will kick away and get rid of. And when you look at the structure and read up on the enzymology of sulfite oxidase, it has a cofactor called molybdoterin. Molybdoterin binds, it has to be there or the enzyme doesn't work. And you can't convert sulfite, and you build it up in your body. And that's what happens to a lot of autistic children. And molybdoterin, there are two thiol groups in the pterin group, PTERIN, in case that, and the molybdenum sits in there chelated. Okay, it's sitting there between two sulfur groups. Now, what would displace that? What would cause that to go down? Mercury. And so if you say, why does mercury cause people to have higher sulfite levels? Well, mercury would be an inhibitor of molybdoterin's structure, that it would decrease it, interfere with it, however you want to look at it. Now, we haven't done those studies to show that, because I mean, I'm old and I'm retired and I didn't have the money. NIH didn't want to fund any of that kind of research. But so when you are mercury toxic, you are very likely low in molybdenum. And so whenever we found several, there were very few, but it was a very rare thing, but autistic children that could not take NBMI because they would get rashes. And then when I did my studies on that, what would cause the rash, it would be the sulfite and they're thiol-sensitive. But I would have the mothers put them on molybdenum supplementation, normal, like you would buy at Walmart or Kmart, Kmart at that time. And when you did that, it would reverse it. I mean, they would lose their sulfite sensitivity.
Right.
And so I have done that. For example, one grandmother who had an autistic child and who was sulfite sensitive, I talked to her and I said, and I was just curious, this is my way my mind works. I asked her, I said, do you drink wine? And she says, no, I can't stand this stuff. It makes me sick. I said, well, why don't you, she said, one sip of red wine and I just feel terrible. I said, well, why don't you do this? You go to the store and you take a molybdenum supplementation for a long period of time and then see if you can drink a glass of red wine. And she did. And she was alive. She was kind of taken back. And so if somebody is out there and they're sensitive to drinking wine because of sulfite in it, make sure your molybdenum levels up, and you may not have that problem.
Right. I think that I suspected that I had mercury toxicity 4 years ago, I believe. And I also developed thiol-sensitivity, and molybdenum does make it better. Speaking of which, does OSR have any kind of affinity to molybdenum? Because if we take both at the same time, could it bind molybdenum?
If it's a molybdenum cation, yes, it would have an affinity for it, but it doesn't seem to be a problem. I mean, like I said, that's the reason I took it for a long time myself, and I don't have any trouble.
Anyways, just to be safe, it would probably be better to take it far away from the OSR.
Oh yeah, I would not take them at the same time. I wouldn't take any mineral supplementation at the same time with OSR because it hasn't been studied enough.
Right, I understand. Yeah, so regarding the sensitivity and to very low doses of OSR, I just hang out on communities of people who are metal toxic, and they claim to have very, very high sensitivity to transdermal OSR. Actually, people like myself who started on toothpick doses of OSR back when we took it, and just to make sure that we were not sensitive. But on this note, should the detox pathways of somebody, phase 1, 2, 2.5, and 3, be opened before using OSR? I mean, let me rephrase this question because it may sound like a little bit. The idea is, would you advise people, and of course that we are, most of these things are theory. They were not, I understand that there are not studies on humans to arrive at very solid and sober conclusions, but would it be reasonable to think that somebody has to work on their detox pathways before starting taking OSR? Because OSR is going to chelate the metals, and whether we like it or not, it is going to add to the burden of the detox pathways. So should we work on them before working on the liver, working on the lymphatic system and whatnot?
I would say the number of people that would have that problem would be so small that it would be more, it would interfere more with use.
Gotcha.
I think, look, OSR is not going to kill you. The worst thing that's going to happen is going to give you either a headache or a rash, a small rash that will disappear the minute you stop. So if you have that, it will let you know if you want to find out if you have a problem with molybdenum. OSR will tell you right away, because it does. I mean, and I can't tell you how many people, there've been a number, I mean, more than 5, that had rashes when they took OSR that went away when they took molybdenum supplementation. And I have found very few that have been unable. I mean, if you have a bad P450 system, you have other problems.
Yes.
I mean, you would know about it right away. I mean, because it affects a tremendous number of drugs that people take that they have to be able to get rid of.
Yeah, even if the person is not taking OSR, there's lots of symptoms and lots of problems going on if they have their P40 450 broken or malfunctioning. Would a sauna provocation, meaning going inside a sauna to provocate metals to float around the body, be potentially useful before taking OSR or after taking OSR?
You know, again, this is what I think. Yes. Do I know that? I haven't done it.
Got it.
But
I think that we should keep this discussion on many things. That what are you thinking, or what do you think about these things, because they are not proven. But I think that over time, I just, my curiosity around these topics made me think of reasonable things to do. And I would like to know if you agree with me, even if they are not proven.
That's the reason I think we have to get it approved for treating acute mercury toxicity, because once it's approved, then medical doctors and university research labs can without a lot of fear of FDA coming after them, get the drug and test it.
Especially chronically sick people, because most of the studies we have them on acutely sick people, right, or acutely poisoned people, and perhaps there's a difference there because the whole body just has tremendous shift when somebody is chronically sick. There's all kinds of problems going on in the body, from the brain to the detox pathways to the kidneys to the liver, and this would be of benefit. Hi, enjoying this podcast? Know that a lot more are going to follow, so please make sure to subscribe to the channel. And also, if you have suggestions on guests to invite to this podcast, leave them down below. Also, I would like to know if you have any particular question regarding this podcast, and if you have any particular comment or remark on this discussion, please do let me know in the comments down below, and let's get back to it. So next question, is there any benefit or a recommendation in stopping a few days after using OSR to give the body a rest, as it is advised in other chelating methods? So you're familiar with the Andy-Kettler's protocol, and they advise people to stop for 3 days after a quote unquote round. Is this, would this be advised with OSR?
Well, that would be debatable. I have not seen where anybody required that. The average person that takes it does not have to wait. I mean, it just keeps going out. And when we've tested it in rats, where we made the radioactive compound and gave it to rats, half of them having been made mercury toxic and the other half not being mercury toxic, the NBMI went out the same. I mean, it left the cells and the tissues at the same rate. And we measured that for over 300 days.
But sometimes displacing the metals from inside the cells could cause potentially, or in theory, some harm to the cell. Is this reasonable to think?
Oh, yes. And a lot of times when you say, what NBMI does, if we just talk about mercury, NBMI gets into all the tissues where mercury goes. And when it binds mercury, it covers up the electron shells and it renders that mercury atom totally non-reactive and non-toxic. But it doesn't get rid of it. It doesn't take it out of the tissue, and it doesn't repair the damage that the mercury has done. I mean, for example, if the mercury has inhibited some key enzymes like creatine kinase, it doesn't, it may not activate
the enzymes, right? Yeah. So that's the question, whether it would be reasonable to stop for a few days to give the body a rest. But I think it pretty much depends on everybody and how they are feeling OSR and how they could potentially go with it. Is there any chance? Sorry, go ahead.
There's no overwhelming example I can give you where somebody needed to stop taking it that could take it and see a positive effect.
Understand.
Except, the thing is, if you treat somebody and all they have is mercury toxicity, if you treat them for 2 weeks, that mercury toxicity is gone. The mercury may still be in your body like it was in the bodies of those rats that we gave massive doses to, but it's not toxic and it's not causing any problem. But if you have a rat that is mercury and lead toxic, there may be a change when you get rid of the mercury. What does that do to the lead toxicity? It probably drops it down, but there may be things that happen with a combination that we don't know about. And the fact is, if you have zinc in the body and you get rid of the mercury and you get rid of some of the zinc and it starts coming back, there are going to be changes that people are going to feel that may not be positive. Right. And I don't know. I don't know what that is. I think we have to have a lot of studies done before we really understand what is the best way to give and treat people with NBMI. But there is nothing dangerous about continually taking OSR.
Right. I think that this is also the perfect time for me to tell people who are watching this podcast that this is a really promising compound and it needs much more studies, as Dr. Haley's is saying. And of course, that costs money. So if you're interested in developing this compound and be part of the history of this compound and pushing it forward in a reasonable way and promoting studies, please get in touch with Dr. Haley's company and see whether there's space for you to work with this project and help the project in any way. Another question, Dr. Haley, is there any chance that OSR activates mast cells or viruses? Have you heard of somebody who complained about viral activation or mast cell activation after using OSR?
No, I will tell you, I wrote a grant to the American Academy of Medicine when they asked for ideas of compounds that might fight COVID or viral infections. And there are these publications done primarily in a university in Italy, in Rome, Italy, where they take viral tissue and they put viruses on it, HIV virus, influenza virus, hepatitis C virus, and they try to add compounds to see which compounds would kill that virus or eliminate its activity. And the thing they found that was the best was reduced glutathione. It stopped the viral replication almost immediately and went in. Now, if you look at OSR, it looks like 2 glutathione molecules. And we know that it builds up the glutathione levels in people. And when we have tasted it, I mean, since I started taking the compound, I have not had a single day of a viral infection where I have a fever or anything else. If I feel one coming on, if I feel a little down, I double the NBMI because I know it, I think it's antiviral because it builds up the glutathione. So at the very least, it would do that. And there is the potential that NBMI, because of having that thiol group, if you look at those 2 arms, they look like extended arms identical to that coming off of glutathione. They could possibly prevent the virus from replicating. So no, I have heard the opposite. And I can tell you, I myself can tell you, and I married to a retired nurse who had, for early on, and when I first started taking this, had to take a flu vaccine to keep her job, working in the hospital. And whenever she took the flu vaccine, she would get sick. And I wouldn't take the flu vaccine. I mean, I never have.
You
I
have to, right?
Well, that's a long story. I mean, I know that, I'm sensitive to thimerosal, for example. So I don't take, I never took, but when I took and I'm was an avid duck hunter. I mean, I like to go out in the cold. I mean, I enjoy it. And every time I did that, once I went overextend myself, I would get the flu. I haven't had the flu since 2006. And that was the same year I started taking the compound when I found out it was totally safe at 1,000 milligrams per kilogram body weight rats. So no, I think that they're going to find that this is one of the fears I have, is that people in the know who like promoting vaccines are going to see that compounds like my compound, like ivermectin and hydroxychloroquine, that stop viral infections without vaccines, they're going to do everything they can to stop it.
Right. Gotcha. Very helpful. How about mast cells? Have you heard anybody commenting on taking OSR and having a mast cell activation, anything like that?
No, the only thing I've heard is a person that had myeloid leukemia and was taking Gleevec to get rid of keep his cell, his myeloid leukemia cells down. When he took OSR, his myeloid cells disappeared.
Oh, wow. Gotcha. Very insightful. I've also seen people online claiming that they have issues with yeast flare-ups, Candida flare-ups, for instance, when taking OSR. Is this possible in your mind?
Well, it's possible, but I haven't. I mean, we've done a lot of studies, tightly regulated. Not people sitting around that you don't know what they're eating, what they're drinking, or where they are. But we have now done at least 7 different human studies. We have never seen any problem with that. And
right.
Some of these people were very sick. They either had Parkinson's disease. We did a study on people with thalassemia. We did a study on people with COPD. We've never had that reported.
Gotcha.
It may happen though. I mean, stuff like that. God, I mean, medicine is very complex with humans.
Absolutely. And this is why we need more studies. Speaking of studies, do you think that once FDA approves the compound and it is used widely in medicine, in conventional medicine, that's the route for having clinical trials in chronically sick people? Or do you expect to have these trials in chronically sick people? Because most of the studies that we have right now on OSR were done on acutely sick people. The question is chronically sick people. Would it be reasonable to think that once FDA approves the compound, then more studies are going to pop out in this kind of populations?
Yes, I do. I think that it's going to be used a lot because the FDA only controls the United States. And but the FDA, there are so many countries that will not give approval for a drug until it's FDA approved, because they know the FDA, and they do. The FDA beats you over the head badly and makes you do tons of studies to show a compound is not toxic.
Right.
I mean, you show it in animals like 1,000 milligrams for 28 a day for 28 days in rats, and there wasn't a single drug-related adverse effect.
And that was huge. Yeah, that's a huge amount for a rat.
And we went up to 5 grams per kilogram on a single day dosage, and it didn't do anything.
Oh, wow.
And so you would think that would be enough. I mean, most foods would cause you a problem if you gave that much. And but they so they're very strict. And so, like if I go to the Philippines and try to sell the compound there and give it to them there, they say, well, we're not going to approve it until the FDA approves it. But when the FDA approves it, it costs me maybe $2,000 to get it approved in the Philippines. But you got to have the FDA, everybody follows them.
Right. Yeah, that appears to be the bottleneck. So regarding just to close this section of toxicity of potential harmful effects of OSR, There is one that is known that is for people who have problems with the sulfite conversion, right? And that's the only problem known for people to take OSR, right?
That's the only one that I can identify with you and say it makes sense. I know why it happens. And it really happens in people that are short on molybdenum.
Right.
And if you've been mercury toxic for a long period of time, you're very likely short of molybdenum in your body.
Yeah, I think that I was just lucky with the fact that I supplemented with molybdenum for a long time before I actually took OSR myself. Otherwise, I would have had problems, I believe.
Well, there's an interesting veterinarian study that you might want to look in the United States. Animals that grow up in areas that are low in selenium and places like that, and molybdenum have medical problems. And they have to supplement that. They put that in their salt blocks for the cattle. And this ended the study. I mean, veterinarians have done, groups have done more studies that make sense than anybody else with regard to supplementing molybdenum to make sure animals stay safe.
Actually, my previous guest, Dr. Russell Jones, we were talking about that. Veterinarians and cattle producers, they have to have a product at the end of the day, otherwise they will starve. And so they make sure that they use the right supplements at the right time in the right forms. Otherwise, the cattle is not going to be as profitable. And that's a very, Russell Jones says that it's a very good lead to follow. If they use one particular form, it is because it works. And that's very insightful.
And I'm hoping to be able to work with people like that, because I can't treat people, but I can treat fish and I can treat animals.
Absolutely. Absolutely.
And I have done some very interesting studies with fish and OSR.
I think that cattle, especially here in Portugal, we have regions in Portugal where cattle is just selenium toxic at times and very selenium deficient in some other areas. We have various imbalances of minerals here, and that would provide the adequate platform for us to test OSR in that context. Speaking of which, people use stainless steel spoons sometimes to grab OSR and take it. In my mind, this is a problem because the stainless steel spoons have metals in them, including molybdenum. Do you think that this is a problem?
I suggest people use plastic spoons, but I don't know. Again, that's what I think and what I know. I think it would be safer to use a plastic spoon.
Yeah, that's what I use. And in my mind, even for some reason it is safer to use a plastic spoon. Okay. How about taking OSR directly from the freezer? So say that people bought a lot of OSR1 back when it was over the counter, FDA approved, and froze it, and they still have it in the freezer. They take it out of the freezer and they ingest it directly. Do you think that this is safe, or do you know if this is safe?
That's exactly what I do.
Okay, if it goes to room temperature.
And I would back up.
Sure. Because
I have paid for, so I know the results, numerous studies. From the day I started making OSR, I kept samples and we would check it to see, does it ever break down? As long as it's in a powder form and it doesn't even have to be in the freezer, it's incredibly stable. The FDA has given us a 5-year shelf life. I mean, a compound, if you keep it dry and it's sealed, and even if you try, I mean, it has an incredibly long half-life. And I've had some that's been over 10 years old that I've had people read, and we do that all the time with the people who make it for us, because I want to know if it's breaking down. And the FDA really pushes you on that. And we have shown them the compound, just if it's dry, until you put it in water with some sort of oxidation or some sort of product, it doesn't break down at all.
Right.
So
how about, right.
If you have some OSR that I made 20 years ago, it's probably still safe if you haven't broken open a capsule and you kept it sealed and away from.
And even safer if it was in the freezer, right?
Oh yeah, a lot safer, yeah.
Yes. How about if the OSR goes to room temperature and defreezes, and then we put it back in the freezer? Should there be any problem? Right. Okay.
No. The problem, I want to take this opportunity to tell people the problem with the Chinese or the chemical thing. When I first started making this compound, trying to get it to pass the regulations and the safety that the FDA wanted for food supplements, the hardest thing we had to do was to get rid of the chloroform. You make it in chloroform or some solvent, and that solvent usually is not good for your liver. And so you have to get it, you have to precipitate it out of that and get rid of all of that chloroform. For example, in my case, it was chloroform. And how you work that out is very important, because if you don't precipitate and redissolve and reprecipitate in the right scenario and at the right time and in the right volumes, people taking the Chinese knockoffs, if they're not doing that, you're going to have chloroform or whatever solvent they make it in, and it could affect your kidney and your liver.
Gotcha. That's very insightful. And by any chance, the Chinese are doing this, right? They're probably using solvents that are residue in the compound and accumulating probably in the body if people are using the Chinese version.
Yeah, and I worry about it because people I talk to say anything made in China is going to be contaminated with lead, because everything they have there, or mercury, because of the contamination of the environment. And I don't know. I mean, that's I'm telling you what might be possible, but I don't know the answer to that.
Right. I think that many of these questions are definitely what's possible and what's reasonable to think, because it's really groundbreaking and new research that should definitely benefit from more studies. How long does the OSR mercury molecule stays in the body? And can for some people last much longer, especially if they have like a detox impairment?
No, we have shown that it goes out as fast as mercury goes out by itself. If you understand, mercury leaves the body. That's been highly studied. It leaves the body as the diglutathione complex, a sandwich complex, mercury and two glutathione molecules attached to each side in the binding coordination sphere. And it goes out and it takes a long time. So we have done these studies and we publish them, present them to the FDA, where we make a rat mercury toxic, not enough to kill it, but enough that it has mercury in his brain and mercury in his liver and his kidney. And then we take half of those rats and we treat them with OSR, and in the other half, we don't treat them with anything. And we measure the mercury. We will know the effect of NBMI on the mercury excretion. It does not make the mercury excretion go faster, but it totally stops the oxidative stress and the toxicity of the mercury. Rats that are not given NBMI lose weight.
Right. So it basically renders the mercury non-toxic until
not reactive at all. I mean, you can't do anything. And again, I want it to get out so other people can do the same studies, because people say, well, that's Boyd Haley saying that. He's always going to give a good rundown of his compound. No, I don't lie about anything like that, because you'll get caught.
Right. What I like about your work is not only the how beautiful OSR is, but also the fact that you say up front, I don't know everything. And if people want to do tests on this compound, please do. Let's get this approved by FDA and then run this compound and know the heck out of it before using it. I think that's very ethical of you to say. Thank you so very much for that. But in an ideal world where someone is not metal toxic and still uses a lot of OSR, and the OSR is for some reason not going to bind to metals because there is not enough of them for it to bind, how long does the OSR molecule stays in the body? Will the body also get rid of the excess OSR?
We've done that, yeah. You can't detect it anymore after 72 days. And this is with radioactive C14 labeled NBMI. You put it in there, and after about 70 days, it's all gone. And that's with one dose, 1 day, and then you follow it. And so no, it goes out of the body. It doesn't stay in there a long time.
Right. And it also goes out of the body through the feces, regardless it's bounded to metals or not. True?
Primarily. But now when you say that, the compound is not charged, so the kidney cannot filter it like it filters charged compounds and get rid of it. But it does also. If you look at albumin, human serum albumin that's in your blood, it has a hydrophobic hotspot on it that binds hydrophobic molecules like NBMI. That's how you disperse fat around your body when you eat a steak or a pork chop. And NBMI would bind to that. And when in the early stages, when some of that is still bound to the albumin, you would filter some albumin containing NBMI bound to it, and they would excrete it, but it goes down dramatically. When we take rats that we've made mercury toxic, and we can sacrifice, we can measure the amount of mercury going out in the urine and in the feces, because you can collect it. Most of it's going, there's a huge amount going out in the urine. But when you give them NBMI, it shifts. That level goes down dramatically. It doesn't go down to zero, but it goes down dramatically, and the amount in the feces goes up dramatically.
Let me see if I understand this. If there's OSR floating around that may be caught, quote unquote, caught by the albumin, because the albumin binds to a lot of things, including testosterone, for instance, that one is going to be excreted by the body through the kidneys.
Well, like albumin goes out.
Exactly. Okay, got it. So in theory, if somebody's chelate is very, very metal toxic, has all kinds of metals going around, uses OSR bound to the metals, is excreted through the feces. In theory, that person should aim at have one bowel movement a day at least, or more if possible. Is this reasonable to think?
I would think so. I mean, but listen, once the mercury, if you're talking just about mercury or lead or some that we have studied, once it's bound by NBMI, it
doesn't cause damage anyways, right?
It's not toxic. It's not gonna, it's just like having a neutral, nothing in your body. Right. Except your body wouldn't agree with that. Your body has a P450 system to get rid of everything. It doesn't.
Exactly. But what you're saying is that in theory, it doesn't make a difference to excrete the OSR mercury molecule, because even if it is in the body, it doesn't create any kind of toxicity, right?
And I have also.
It just speeds up the process of getting rid of the mercury if someone has a daily bowel movement, right?
Yeah. I do want to point out, I did a study a long time ago where I made the mercury NBMI complex in my laboratory, checked it out, got the, had all the analysis, and it was mercury NBMI complex without a doubt. And I sent that off to Southern Research Institute in the United States to do toxicity studies. They gave 2 grams per kilogram body weight to rats. It didn't kill them. It didn't even make them sick. And they did a week of giving 500 milligrams a day per kilogram or something like that. But the analysis from the Southern Research Institute is that mercury NBMI complex at levels way above the levels where just mercury would kill a rat, did not induce any toxicity, even though some of it got into the body.
So you mean, I'm sorry, Dr. Haley, perhaps I was lost there. You said that they were giving the rats the OSR mercury molecule itself?
Yeah, the complex put
together. I understand now, right? And that didn't create any kind of toxicity, right?
That's a sensible thing to do, to say, well, are you making something toxic in the body? And according to them, there was nothing toxic, and they did that for 2 weeks.
I understand. That's very insightful. Thanks. How about running a stool test to check for metals? So there's a laboratory in the US, Doctors Data, that tests feces and the amounts of toxic metals. If the OSR molecule is already bound to mercury, so we have the OSR mercury molecule bound together being excreted in the feces, will it still show up in this kind of tests as mercury?
Yes, because they incinerate it. I mean, that's an ICP mass spectrometer, inductively coupled. It means it goes through about a huge, they burn it up and kick the mercury off. So I think it would, but that's what I think. That's not what I know, but I'm pretty sure it would show.
Anyways, if somebody wants to do this experiment, it should contact the lab first and ask them how about the procedure, how the procedure is done. And if it is incineration, I assume that OSR has this boiling point after which it just disappears. And so the mercury would precipitate and be measured that way, right? Okay. Yeah. Let's assume we have 2 last sets of questions, and I'm so lucky to be talking to you. I feel so excited about this. Thanks so much. Seventh set of questions. Let's assume somebody with mineral derangement on an HTMA test, so hair test. That person thinks, I mean, I didn't know that you actually preferred urine and blood to test for metals, but your point is a very good one. our hair is exposed to everything, so blood and urine would be a better way. But let's say that that person is convinced that he or she has mercury toxicity and has been using OSR at 200 milligrams a day at a time. 200 milligrams in one day, in one shot. No progress in symptoms at all. And I recall a study that you cited with minors where you showed that excretion of mercury was significantly higher when you dosed 300 milligrams. Do you think it is reasonable to think that people who dose 200 milligrams without results should aim to dose 300 milligrams for a few, let's say 6 months, and assess the results by then?
But, again, it goes back to, what we think from what we know. We're doing a study now in Colombia, South America. We've got it approved by INVIMA, and we're giving these people 600 milligrams a day because we think that will, one, it'll be safe. We've tested in humans. 600 milligrams of NBMI doesn't affect any human, and it just allows you to get all the mercury. I mean, it's an overwhelming approach to getting rid of the mercury. I don't know, the problem with hair, mercury that gets into your hair has to go through a living cell. You know that?
Yes.
I mean, it has to be incorporated into proteins and put in there. And I don't know if NBMI mercury would be incorporated into that hair protein. I mean, it binds mercury, but I don't, I mean, I haven't, so I don't use that because I don't think anytime the mercury is bound to something unusual, it's very likely not going to get through the cell and get into the protein of the hair.
Right, that's very insightful, but I think that, and that's how I see it, whenever people use hair analysis to assess mercury toxicity, we don't look at mercury itself, we look at the mineral derangement. If all the minerals in the hair are pretty much deranged, meaning that many of them are higher than what they are supposed to be, and many of them are much lower than what they are supposed to be, mercury causes that. And so it's an indirect test to assess for mercury toxicity. But that's very insightful, the fact that you don't know that if the OSR mercury molecule would go to the hair, because you don't know whether it gets incorporated in the proteins that get to the hair.
To incorporate into protein, it has to bind to something. And I can tell you, you can't get mercury to bind to anything once OSR's chelated. It covers up the entire electron shell, and there's no ability to even get reactive thiols to bind to it.
So in theory, if that is true, then in theory, the hair test would show much less mercury because there's non-bound mercury or non-OSR bound mercury in the body that gets into the hair. So
that's what I agree with that. Yeah.
Yeah. This is an indirect test as well, but one that makes sense. But my question was more, do you think that there's, from the studies that you've conducted, is there any tipping point of dosing OSR after which the results are much more visible? Because like I said, in this scenario, this person has been using 200 milligrams of OSR without seeing much improvement. And from the tests that you conducted, would it be reasonable to think that if this person dosed 300 milligrams or more, he or she would have better results?
Okay, well, I want to be very careful because this is important for people to understand. I mean, if you're talking about taking OSR orally and then measuring an effect in a person that has that's very healthy or reasonably healthy versus someone that's suffering from a high level of oxidative stress, when you take that OSR, if you have a high level of hydroxy free radicals in your body, the first thing that OSR is going to do is scavenge that hydroxy radical and form a sulfide. And when it does that, it will no longer bind the mercury.
I understand.
So this person is taking 200 milligrams a day. And that's the reason when we gave 100 milligrams, you didn't see a third of what you saw with 300 milligrams with those Ecuadorian miners, because all that 100 milligrams is probably being consumed by hydroxy radical formation and scavenging by NBMI. And that is one thing NBMI does incredibly well, the scavenge hydroxy free radicals. I mean, its ORAC score is just out of sight. That's the reason we sold it as a dietary antioxidant.
Exactly. And that's probably the case in most chronically sick people. They have lots of oxidative stress. And so the OSR is not primarily, but firstly working on lowering the oxidative stress in the body and then going after metals. I understand that. But in this case, I wanted to make another point. Perhaps I'm lost now, but I understand that. So in principle, I know the point that I wanted to make. This person was actually able to measure in blood through indirect markers the oxidative stress of the body. For instance, with gamma GT, a parameter that is also linked to oxidative stress in the body, and it was extremely low and actually got much lower to 1 or non-readable while using OSR. So I would say that this particular person was not being afflicted by a high oxidative stress, but still he was not seeing good results in terms of symptoms that he associated with mercury. So that's the question. In principle, if we have this scenario, we would dose OSR higher, right?
Yeah, but that he's an N value of 1. And when I read a lot of research on autistic children, it was amazing how many of them were totally different than other autistic children. But the one thing everybody agreed to, autistic children suffer from oxidative stress. And so if you're suffering from oxidative stress and NBMI helps you, it doesn't mean it's binding mercury. It's probably binding the unbound iron that's released by whatever toxin is causing the autistic development or the oxidative stress. And so, that makes it very difficult to blame any metal, specific metal, because when NBMI goes in, it will bind the iron, and iron is usually the redox metal that causes oxidative stress. And the oxidative stress probably does more tissue damage to a sick person than the original toxin.
Have you
found a herbicide or a pesticide? They probably cause most of their damage by inducing oxidative stress. In other words, the pesticide will bind to a protein and cause iron to be released, and then that iron starts generating hydroxy radicals.
Yeah, iron is super important in the human body, but highly oxidative as well. If unbound and in the wrong time at the wrong place, it's very, very detrimental to the human body, for sure. The question then would be, did you find any hack or any hint that suggested that you could use a hack like dosing OSR 2 or 3 times a day, so that some of it would primarily be used to reduce the oxidative stress in the body, and another dose to go after metals? Is there any hack of using OSR to actually get the chelating effect that you know of?
Well, I would say that the indications we have, these are unpublished data, is that when you go up with increasing NBMI and you're looking at mercury toxicity protection in tissues, it doesn't go up. I mean, the lower doses don't have the effect they should have percent-wise, because every tissue, every cell in culture that's growing has oxidative stress involved. And when the first thing the NBMI will do will be react with the hydroxy free radicals. And then once it does that, it can't bind. And so the first 10%, let's put a number to it, just so people, the first 10% you take in there is going to be consumed by taking care of the oxidative stress, even in a normal person. Every normal person has a level of oxidative stress going on too. And when we did this with culture, when we added NBMI to cells in culture and treated these cells with mercury, or methyl mercury or thimerosal, we could see the glutathione levels drop dramatically. And then if we added NBMI, the levels would not drop, they would go up. But even in the controls where we added no mercury at all, we saw a doubling of the reduced glutathione with NBMI. So NBMI is good for a healthy person. If you say higher levels of reduced glutathione are going to keep you from being affected with a virus, which I believe is true. I think high glutathione levels are really what prevent viral infections.
Which was also verified in the study that you cited in Italy that showed that glutathione is very antiviral.
And there are a
Yeah.
lot of people, I think the real weakness in American medicine is our need for money, to make money. If you're going to do something that's going to prevent any aspect of medicine from making a lot of money, they're not going to like it. I mean, FDA is not going to like it, because I think they have, again, I want to say, this is my fear, is that they're more interested in keeping pharmaceutical companies making a lot of money than they are in getting a drug that will stop all the diseases. Because, when they shut me down, their response to me was that these ladies on blog sites were saying that my compound was the best compound for treating autism. And therefore you're taking a supplement and treating a disease, and it can't be a supplement. It has to go through the thing. Well, then why didn't they come back to me and say, hey, autism is a major health problem in the United States. We're having real problems. How does this work? How can I put you in charge or in contact with people treating autistic children to see why your compound's doing this? The FDA had no interest in promoting any compound to relieve the autism epidemic that was going on at that time. And it was a major problem, and it still is.
And the other question that should be raised there is, if some of these moms on blogs would post that drug whatever was the best thing for autism, would they go after the pharmaceutical companies and shut them down as well? I don't think so, right? But
No, I don't. They made it pretty clear with me, though, that I could not continue to sell this as a dietary antioxidant. And you got to understand, in 2 years that I sold it, it was cheap. I kept it cheap. And in the 2 years I sold it, we didn't have a single significant
collateral
drug-related
damage
adverse effect reported.
Right.
And so they're not doing it to protect people. They were doing it because I think that some medical group was complaining that I was successfully treating children with a major disease and taking money away from their treatments, their profession.
And I'll take that note to ask you, what's the situation right now in terms of getting it FDA approved?
Okay, we have done successfully with no problem at all. We haven't had a single drug-related adverse effect report for NBMI. We've done all of the developmental and reproductive toxicity studies. We have done animal studies in 6 different animals at least. They keep asking for more. We haven't found anything. And so I think the last meeting we had with them, they agreed, well, 2 meetings ago in March of 2019, we had a meeting with them, and they said, we think you're going well, but you're going to have to do this under the animal rule, FDA animal rule. In other words, we have to show efficacy with animals because you can't do that with humans. You can't give this much. And so we said, okay. They said, well, develop an animal efficacy study and submit it to us, and we'll see if we'll approve it for marketing authority. And so we did that. We spent a year and a half taking rats, and we had to do it. We got ran over by COVID. People couldn't get test animals from the United States into Europe because of COVID. But the bottom line is, it was very easy to show that if you injected rats with low levels, starting up, going from 0 up to a levels that cause kidney failure, that you could make rats that had toxic kidneys. The kidneys weren't working right. And then if you gave NBMI, if you gave it ahead of time, it would prevent it. And if you gave it afterwards, it would increase the recovery time. I mean, it would make the recovery time better. And we sent that to them. We had a meeting with them just this last summer, and we showed them that data. And they said, you have convinced us that your compound is totally safe. You passed all the toxicity studies, it's safer than aspirin. But they didn't say that. I said, but they couldn't find
right. It's very safe.
Nothing toxic uncovered by the compound, because we had done studies with people with thalassemia, people with Parkinson's, people with COPD, Mexican miners that were mercury toxic, and normal human beings that were healthy. None of those studies have ever shown a single drug-related significant effect that would be life-threatening. I mean, they can always say, well, this guy didn't have a bathroom bowel movement on time or something, but but there was nothing like that. But they said, so you have proven that it's safe in humans and safe in animals. and you have proven that it's efficacious in test animals, but you haven't proven it's efficacious in humans, and therefore you can't apply for marketing authority until you do that. And we ask them, well, where in the United States can you find a clinic that treats people for mercury toxicity? There isn't one. Where can you find a group of people that are mercury toxic according to FDA regulations? You can't find them. The people that, there are people that have very low mercury levels and claim that when they get their amalgams removed, they get better because they're not excreters.
Right. But that's just anecdotal evidence, right? That's not. So
we have to. So yet the bottom line is, they say we have to do a phase 2, phase 3 study on mercury toxic human beings, and we have this set up right now in Colombia, approved by NVEMA. We've done the application. We've changed it around a few times, and so right now we have it all set up, and we have money to do about half of the study. But you're not going to do 100 people in one time.
Right.
They're going to do.
So this could go through phases, and the money could be deployed as you go.
Yeah, and that's what we're setting up now, so that we can get, say, the first 20 done and look at the effect. And what I can tell you from people, even people taking the Chinese, if they take the time to have their urinary mercury checked before they start the Chinese product, that's 85-90% NBMI, they're going to see that the urinary mercury levels are going to drop dramatically. That's what we saw in the Ecuadorian minor study. If we gave we gave to the 300 milligrams, 10 of 11 showed major drops in our urinary mercury because it could tie it up with NBMI, and it goes out the fecal route. And hopefully we'll get that done. But if you know of anybody that's willing to support, I need help. I need financial help, and I won't keep any of the money. It'll all go to the company.
We all understand that, and our community is very supportive of you, Dr. Haley. And I'm hopeful that this podcast reaches the right people. We're talking about sort of roughly $500,000 to complete the study, right? And hopefully this will reach the right people and raise the money that is necessary, because this does seem like the last stand to surpass and have it FDA approved, right?
Yeah, and what I want to say is we're not asking for handouts. We give stock in a company that will probably more than pay back, because this compound is going to make most other drugs work better. Like Tylenol. This compound inhibits Tylenol, stops Tylenol toxicity.
Right.
And Tylenol kills 500 Americans a year about. And this compound, it's got a lot of uses other than just treating mercury toxic patients. For example, I did a study with the zebrafish. I had 2 tanks that I set up with zebrafish. They're a kind of an ornamental fish. And we kept them for 2 weeks, and then we fed them Walmart fish food, and I took half that fish food and mixed it with OSR. OSR does not dissolve in water, as you remember, but it would stick to that fish food. And when you put it on there, the fish would just eat it with the food, or if it was there by itself, they would eat it. And we did that. We did that for about a month, and the fish never died. They looked healthy on both tanks. And then we decided to do the final, when we were going to end the study, let's see if it made them less toxic to mercury. And so then we had a container of mercury chloride, and we took drops. We started adding a drop to each side.
Each tank, right? Wow.
And
what was the result of that?
And the fish without the mercury, with the NBMI, they died very quickly. And the others, we just quit because they just would not die. And I don't know, I don't think it's the NBMI floating around the water. I think it's the NBMI getting in the fish and collecting in their bodies and protecting them from heavy metal toxicity. But that's something, again, that needs a lot of study.
Right. And how much time did it go between the last dose of OSR to the fish and the mercury?
I don't recall how long it was.
Right.
It was maybe at the most a day or two.
Right. But my point was it would have been less than the excretion of the OSR inside of each fish, right? because
Yeah.
then it would not be,
Yeah.
which for human beings is 72 days, you said, right?
Oh, I would say that NBMI, if you take it, it's there at an effective amount, at least 22 hours after you've taken it.
Right.
But
Okay.
I wouldn't want to say any more than that because,
Right,
but
I
it's
understand.
longer than that to get rid of it. There's no doubt about that.
I
And how long
understand.
it would work in your body. If I were going someplace that was mercury toxic, I definitely would be taking a bunch of capsules of OSR with me.
Right, right. Dr. Haley, I think that I'm pushing the envelope here, but I have
Okay.
one last set of questions. I hope that's fine.
That's fine.
And that's comparing OSR to Andy Cutler's protocol, which is widely used on the internet and widely commented. And I see a lot of people debating over using OSR or Andy Cutler's chelation protocol, which pretty much consists of ALA, DMPS, and DMSA. So I'm sure you're aware of his work, and he doses chelators per their half life, basically.
Yeah.
What do you think of this method, both in terms of effectiveness and safeness? And what do you think of ALA in general as a chelator?
ALA is it is a major cofactor in pyruvate dehydrogenase complex, which starts the citric acid cycle. And if you have mercury bound to it, I would ask people, does mercury ALA inhibit that enzyme pathway? I don't know. I can tell you from chelation, and I got in a fight with Andy about this when he was alive. It does not make a stable complex like NBMI mercury. It just cannot form that type of. And I would just say, show me the science. I mean, they're allowed to do that. And and the fact that it involves the use of DMSA tells me it's not very safe. DMSA is not a non-toxic compound. It has a level of toxicity that's quite significant, and it gets in there. I mean, it will not be nearly as good as NBMI. How can you get any better than NBMI? I mean, you can take huge amounts of it. It doesn't interfere with any metabolic pathway, like ALA is in the citric acid cycle. I mean, it's a cofactor that's involved in that. If you mess that up by getting too much, too little, what effect are you having on that biochemical pathway? Our compound is not involved in any biochemical pathway, and it binds mercury and it just renders it non-toxic. We have tested it. You can't give more to animals than what we've given. I haven't seen a study where they've given 1,000 milligrams per kilogram of lipoic acid per day to rats.
Right.
We've done that. And so, and I don't like being critical of things that I haven't had my hands in. And Andy, I can tell you, I found his biochemistry wanting. And he wasn't a person that would want to discuss the problematics of it. If he was right, he told you he was right, and he knew he was. So I mean, he and I did not have a lot of discussions, to be blunt, because he just got his feelings hurt too easy.
Right.
And but there's no way that Andy's protocol is going to work as well on autistic children as did the compound that I have. And in my compound, one advantage it has, you give the kill. We treated children with 1 capsule a day, or 1 treatment a day. They may give them 2 capsules. I don't know what they did, but what I would say, and I guess the biggest disappointment in my life has been that the autistic parent community has not, even though they know their people have said their children improved dramatically, and there were a large number of them, they haven't got after the FDA for taking this away from them. It's like, well, you're allowed to give our kids something to make them sick. I mean, for example, gadolinium contrast agents, we can do that.
Right.
But you cannot, here's something that does nothing but make kids feel better, and you're taking it away from us and tell us why. Where's the discussion? I mean, because the FDA doesn't give a rat's rear end what I think. They might care what a group of 1,000 autistic parents think, and they just dropped it. I mean, they just, once the FDA shut me down and accused me of using what they call it, a commercial chemical to treat autistic children. It was made like a drug. It was made very, very carefully. And it wasn't like taking something off of the beltway of some chemical.
Method. Right. Understood.
And the thing is, I did not. And here was the catch. If I had published the data that I knew on mercury toxicity with my compound, the FDA would have shut me down, because then it's a medical compound.
Right.
So I could not publish that mercury data showing that it was totally safe and totally prevented mercury toxicity. Because at that time, and it's published now, it's in 2012 Clark paper, it showed that it's totally prevented death from mercury. And death is a good endpoint. You can argue with it. And the FDA still wants us to find a biomarker. Well, death is more a better biomarker than anything you can get.
Absolutely.
I mean, if you stop death, you've stopped all the biomarkers from going out of whack.
Yeah, absolutely. Coming back to the comparison with ALA and Andy Kettler's method, if somebody's taking ALA for its half-life, say 3 hours, and is having results of some kind, it doesn't really mean that the mercury levels are going down, that symptoms are being treated successfully because mercury is going down. That person is just finding ALA useful. Would it be reasonable to think that when they stop ALA, there's probably mercury floating around in the body and they should use OSR at the end to mop it up?
Well, yes, but think about this. When mercury, if you do studies on pyruvate dehydrogenase complex in the mitochondria of rats, and you feed those rats mercury, do you think that mercury doesn't go in there and bind to the ALA, which does that catalytic transfer of the acetate at the pyruvate dehydrogenase complex? That you're treating animals that have probably inhibited, or humans that have inhibited ALA that doesn't work because it's got mercury bound to it, and you're giving it ALA that's fresh. And you may activate that citric acid complex, but you don't get rid of the mercury.
Right. But still, ALA would displace some of the mercury, right? Would make it float around and excrete it from some of the tissues, not necessarily from the body, because it's not a true chelator, but it would displace it from the tissues in your vision, right? And then using OSR after the usage of ALA would be sort of an insurance policy, because this is it's more or less the same rationale of the question that I've made before, which is, would it be useful in theory to go inside a sauna and create a buzz inside the body and just release a lot of mercury and then use OSR to catch it up? Would it be easier? And I think that this is comparable to using ALA, right? It would be sort of an insurance policy against too much mercury floating around uncontrollably.
I have a sauna, and I use it especially when I first started, when I was trying to see what effect it had. And what I can tell you about taking OSR and going in a sauna, it won't hurt you. I mean, right. You can take it, and I didn't get sick. I can't say that I saw any remarkable improvement either, but it did not. I do know that if you take saunas and measure the sweat that's coming off of people in saunas, you'll see increased mercury.
Right.
Yes, I've read that. I had people that I have a lot of respect for tell me that. Right. So, I mean, what you just proposed, I think would be a good idea.
Right. Okay, great. Would you say that it is absolutely not necessary to dose OSR according to its half-life?
According to what?
Its half-life. The same way that Andy Kettler doses ALA according to its half-life every 2-3 hours. Would it be... It's not necessary to do that with OSR at all?
No, not at all. I mean, and we've had people do that. You can follow, and with our studies, when we did the human studies, we followed it goes in the plasma, and you can follow it all the way, and it has a half-life of 22 hours, in the plasma. So it's there for you. Take it once a day. And it's there. And
right. Got it. But so taking it every 30 hours, for example, would not be different or more effective than taking it every 22 hours, right?
Well, I don't know.
Right.
I mean, you know, there's a, I mean, 22 hours half-life in your body is in the plasma that's a long time. And if you take it once a day, you're going to be safe, and it's going to build up a little bit probably. But like I say, that again, I mean, I'm good at chemistry. I'm good at biochemistry. I have never treated a human patient in my life. And so this is something that, you know, I need to get this tool. I've made a tool, and this tool needs to be put in the hands of the medical people who treat patients, who do their temperature, their heart rate, and everything every day. And that's what I'm fighting for, is to get it approved so that people can write IRB directed things for an approved drug to check out. I mean, who knows what it's best for? I mean,
yeah, this would be a
so many
hint for,
variations that one can have.
yeah, I think that these my hints would be useful in clinical trials. I would love for people to test OSR and test it, you know, per its half-life, dosing every 22 hours or less, doing provocation tests before using stuff like cilantro, chlorella, saunas, before or after taking OSR. I think that primary OSR, I mean, these are things that make sense in theory in my head because of the experiments I've made with a n equals to 1. And I would like to know if this is reasonable to think, and I would like to see clinical trials, obviously, running this ideas. The last question that I have is, ALA has many properties. I'm a fan of ALA, not necessarily for the
I'm not an enemy of ALA.
Yeah, I know, but I'm a huge fan of ALA, not in the sense of a mercury chelator, but I'm a fan of the compound itself because of many properties that it has. But OSR, and I'm not comparing OSR against ALA here, I'm just saying that OSR also has very interesting properties that go beyond mercury and metal chelation. For instance, we've talked about lowering oxidative stress in the body, but also I've learned that there are 3 important properties of OSR. One is being able to fix the glutathione recycling system to some extent. The second one is fixing thiol-sensitivity, apparently. And people reported that their thiol-sensitivity got much better or even fixed entirely after using 20 grams of OSR, after going through 20 grams of OSR. And even being a biofilm disruptor in the gut for biofilms that infections like Candida and parasites create. Have you heard of these properties? What do you know? What do you think? Can you elaborate a little bit more on that?
Well, I've heard about everything, to be honest with you, but bad and good. But what you do know is that free iron, I mean, for bacteria to grow in your bloodstream or in your body, in the
It's gasoline, right? Free iron is gasoline for pathogens.
And NBMI ties that up. And we have done this because we have taken tissues, very complex tissues and cell cultures, and added free iron and looked at the oxidative stress that's induced by, you know, looking at the drop in oxidative stress markers or the increase in it. We did this on the lung tissue from COPD patients. And when you added NBMI, it totally eliminated it. I mean, totally eliminated it. It was down to nothing.
So therefore, it's reasonable to think that infections in the gut, especially that thrive on unbound high amounts of unbound iron, would actually decrease their population just by using OSR, because OSR is going to chelate the iron out of them. And so, right, this would be reasonable to think, right?
Yes, and that's the reason we tested it. We've tested it on Parkinson's disease and on thalassemia, because, you know, if you try, and when we gave it the test that we did with them with thalassemia, you would have to say it was a success, because you're measuring the buildup of ferritin levels in the blood. Our compounds totally stop the buildup of ferritin, just like other iron chelators, with the exception our compound didn't make anybody sick.
Right.
I mean, they could take as much as they want whenever they want, and they don't have the toxic effects that other iron chelators have. So this compound has a lot of promise in the treatment of hemochromatosis And we treated the rat model of hemochromatosis, and it worked excellent. You couldn't ask for a better result than what we got in an animal. Now, how it would work in humans is, I mean, I have some hints because I have some friends or acquaintances that I've given it to. Why wouldn't it work?
Right. How about fixing the glutathione recycling system in the body?
Say that again.
How about fixing the glutathione system, recycling system in the body?
Well, I think it does that, because the one thing that I found out when I was started taking OSR, I went to the doctor I always go to for my physical, regular physical, and I asked him to look at my glutathione levels and red blood cell glutathione levels, because that would be an indication. And he says, we can't do that, and we don't do that. And I said, well, why don't you do that? I said, oxidative stress is involved in every illness. And he says, but what can we do about it? And I said, well, I'm taking a compound I think would elevate it.
Then you educated your own doctor on OSR, I'm pretty sure.
Well, not only my own doctor, ask any doctor. They won't know a thing about glutathione levels, most of them. But anyway, when he tested me, and I was 65 at that time, about 65, and in my late 60s, I had the glutathione levels of a teenager. He got excited. He started taking the compound. He was that excited that somebody could take a compound to increase their glutathione levels. And
did he report to you on his own glutathione levels?
I'm sorry?
Did he report to you on his own glutathione levels?
Yeah, they were, he sent it off. He did not have a place to send it. I had to go find a laboratory that did red blood cell glutathione and give it to him so he could order and send it.
Right, but after he started to use OSR, did he measure his own glutathione levels?
I don't know if he did, because it was an interesting story. He was treating a lady that was diagnosed with atypical Parkinson's disease by the Mayo Clinic.
Right.
And she was coming in, and I talked him into giving her treatments, and I gave it to her free. And she came out of her wheelchair. He said she couldn't, and he wrote a letter. We have a patent on this now. He wrote a letter about how he had never seen anybody as bad in a wheelchair as her, and he had never seen anybody recover from Parkinson's or any neurological illness nearly as completely, because she came in 2 months after she started and got out of her wheelchair and jumped up and down in front of him, just showing how well her balance was.
Right. I'm also very curious on the thiol-sensitivity, because I'm thiol-sensitive, like I said. And you said that many mothers mothers of autistic children basically reported that some of them had to take molybdenum. So you do have some experience with that. Did some of these children eventually became thiol insensitive or thiol normal sensitive after going through enough OSR?
Yes, there were children that, it wasn't that many, because there weren't that many that are thiol sensitive, but there were children that when they started taking OSR would develop a rash, and we would say put them on a molybdenum supplement, and then they start over, and the rash wouldn't come back.
And the question is, would eventually, after going through enough OSR, the children would not develop the rash, even if they were not put on a molybdenum supplement, which would indirectly prove that they're thiol sensitive.
And I don't know the answer to that. I don't know if they ever, they started them on a molybdenum supplement, and I never wanted to play a game. I never wanted to play doctor from a distance, saying, "Oh, then take them off and let me know what happens."
Right.
I don't want to do any experiments on children.
Yeah, I presume that some of them would just stop molybdenum because they would forget it or something, and they would report to you, you know what, those rashes that we used to have, we don't have them anymore, but we are off molybdenum as well. So I think that OSR actually fixed the thiol sensitivity. I was expecting some report like this, because actually, Dr. Haley, I've seen many people claiming online that after enough OSR, their thiol sensitivity went away. And this
Well, I can tell you, I know one adult who worked for me who was thiol sensitive and took molybdenum to get over the thiol sensitivity, and it worked. and he was taking OSR, and he slowly built up. And after he got so high, he quit taking the molybdenum supplement and kept taking the OSR, and it didn't make him have a rash.
Great.
So I think there's something there.
Yeah,
And
that's the kind of report that I was hopeful to hear, because this is the kind of pattern that I see online for some people, not for all of them, but some people do claim that their thiol sensitivity goes away after going through about 20 grams of OSR altogether.
Yeah. Well, I'm not surprised, because, what causes the oxidative, sulfide oxidase to become inactive, is probably just a dietary lack of molybdenum for a long time, and maybe mercury toxicity competing with the molybdenum for that site. You get the mercury level down, now the molybdenum can go to that terin and bind to it properly, and you activate that enzyme. But what we do know is that autistic children have high levels of sulfite because they can't get rid of it.
Right.
Their enzyme, sulfide oxidase, is inhibited, and it can be inhibited by lack of molybdenum, or can be inhibited by molybdenum being displaced by a toxic metal, or it can be genetic. If it's genetic, you're in tough situation, I think.
Right. Any particular story that you've heard of using OSR as a biofilm disruptor, or just having biofilm disrupting capabilities? Biofilms, for those that don't know, that are listening to the podcast, are essentially the substances that pathogenic bacteria and organisms in general develop to protect themselves from the immune system of the body. And sometimes to kill off those infections properly, people theorize that we have to disrupt the biofilms, in other words, destroy them, so that the immune system sees the bugs and goes after them. And I've seen claims online that of people using OSR that says that they swear that the OSR did disrupt their biofilms. Have you heard about this before?
I've heard about them just like you have, but I know no more than what you do.
Right. Okay. Thank you very much. So the last question is, well, two last questions. The first question is, how much OSR do you take? But I think that you answered that throughout the podcast when you said that you just take it every single time you think about it, or you remember taking OSR,
just once a day. And I take about somewhere between 200 and 300 milligrams. I'm so, I'm not taking it because I think I'm toxic. I'm taking it to get rid of oxidative stress.
Right.
Just to keep that down, because hey, one thing OSR doesn't do, it doesn't make you get any younger. Getting older, and and I just what I notice, and this is all, you have to be very careful when you talk about your own health.
Absolutely.
If I don't take it, if I have a weekend, I go someplace and I don't take it, I feel like I have more of a problem urinating. And whenever I feel like that come up, I take a lot of OSR and it goes away. I think there's a lot of oxidative stress in the body that prevents it from operating normally. And you can see I have a good color to my skin. And if I don't take it for several days, my skin will start turning a little gray. I mean, I look more my age is what it comes down to. But again, that's what I think. That's not what I know. And I think
exactly. And these two questions are very personal. The last question is, what do you do to improve your own health? Or if you prefer, what's the thing that you do apart from taking OSR that you think it has the most impact, the positive impact that is in your health?
Sleep. If I don't take OSR, I don't sleep well. And if I take OSR, I sleep well. And I think sleep is a big, I don't know how to put it in that fixture, but sleep is important. Getting enough, your 8 hours sleep, because you're looking at someone that never slept well. I mean, when I was younger, like I say, type A, Irish personality. If I had something on my mind, hell, I thought about it all night.
Just like me. I'm sorry, I just regret I'm not as genius as you, but I'm exactly like you personality-wise.
Don't think I'm a genius. What I am, is I'm a follow your nose scientist. I was well trained. I had a great thesis advisor, Dr. Ralph Young at Washington State University. And he just said, think about things, just think about it. And that's what I do. I mean, when I see something and you have to pull together all the biochemistry and all the cellular, the nutrition, etc. I don't let go. I follow leads if I see them. And when someone calls me like you, I've learned a lot from you. You're telling me things that are not totally unique, but I've heard them before, but hearing them again from somebody that's more exposed than myself, because I don't talk to many people like you. And you guys are going to be the ones that are going to find out that if you take OSR with calcium, you do better than if you don't. I'm not going to do that. I mean, I'm just not going to have that kind of time.
Right.
And I'm looking right now, I'm trying to get the compound approved by the FDA or the INVIMA in South America, so people can write IRBs, medical doctors that want to use it to study, because the FDA won't approve it, and they know it's not toxic. They even say that. I mean, we got the report back, and so how in the hell can I convince a person that's got a clinic in Spain or Portugal or someplace like that they ought to use this because they're worried about the toxicity?
Right.
When there is no toxicity. We've done everything. We have submitted to them an investigator's brochure that's 90 pages long that talks about all the studies we've done to eliminate the effect, where you look at the effect on heart rate in dogs by giving them massive amounts. It doesn't do anything. And this needs to be out there. It needs to be, but no matter what we do, you still have to have that FDA blessing before people will start working on it.
Absolutely. So two final notes. My PhD advisor was exactly like yours. I would come into his office and say, I figured this all out. And he would say, how about this? I mean, think about this. And I would just find more leads and go after them. And I think that was actually the most profound idea and the most profound value that I took out of my advisor that he passed on to me. Precisely go after leads and rethink what we think we know, and sometimes we don't know it well, or there's more to it. And because of my personality being type A, I would just go after it like crazy, and being very late in the office going after all those leads. And secondly, I think that yes, I will try and push experiments with OSR in general, sauna, chlorella, cilantro, calcium, whatever. But I think that our fight globally right now is to get this approved. And so FDA approved, that is. And so if somebody is listening and cares about mercury and metal toxicity, because sometimes it's not only about mercury, there's more metals, but if somebody cares about the potential of OSR, just contact Dr. Boyd Haley and Dr. Haley's company to help in any way possible. Dr. Haley, it was a truly pleasure to be talking to you today. And thank you so very much for all this knowledge that you passed on to us and for your work.
Okay, well, thank you for having me on your program.
Thank you very much.
Okay, so this was the podcast. I hope you guys enjoyed it. Please remember to subscribe, activate the notifications by clicking on the bell as well. And please remember that this is a lot of work for me and I don't make any money off of this. So for me to keep this project sustainable over the long run, I really rely on donations. So if you want to donate, just PayPal me through my email address, which is biohackingmyillness.com. Any donation, any amount will be useful and will probably go a long way. I'm also paying people for to edit the podcasts, the audio, the video, and also help me with the website. So it's really a costly project. And for it to be sustainable, I do rely on donations. So I hope you enjoyed this podcast. If you have comments on guests, any suggestions, you may You're welcome to put those suggestions forward. You can also email me at biohackingmyillness@gmail.com. And any question that you have, just leave it in the comments down below. See you in the next episode. In good health. Bye.